So I should show you my screen. So what we will do, we make COS project. Today I gave you and I comment today your task, and we consider elements, units which are included in your COS project elements. So the task of our COS project is design a drive, mechanical drive, according to initial data I'll give you. And drive, what's drive? Drive is something like this. In our case, it may be one or two engines, and according to diagram, it may be one or two outputs, and maybe at the same time two inputs and two outputs. And gearbox, remind you that gearbox means that it's something which some unit transfer the power, transfer the torque and rotational speed according to power it transfer. So that's why the main element of designing process in this COS project is to create, to calculate and to make gearbox. We will use gearbox with transfer ratio more than 1. That's why it's gear reducer. Another name, reducer, because sometimes it may be multiplier, which increase rotational speed. But in our case, input rotational speed is higher than output rotational speed. So that's why it's a gear reducer. And according to task, you have, I said, one or two engines and one or two couplings. Coupling, it is a unit which connects shafts of two elements. In our case, it is an engine shaft and input shaft of the gearbox. Coupling connects these two shafts constantly during all operation. It disconnects only when it's broken. In such case, disconnect. But correctly operating coupling rotates together with rotor of engine. They have the same rotational speed. This is a coupling. And on output shaft should be one more element unit to connect output shaft with a driven machine. It is not shown here. It is a usually clutch. Clutch is element which connects output shaft and driven machine. All of them, all these elements you see are mounted on a base plate, and all of these elements are included in gear in a drive. Then, what's the gearbox? What we should know about gearbox? I show you
Gearboxes are used in drives of different machines. They are needed to change the speed and the torque. Electric engines' rotational speed is too high, so it has to be reduced. This is exactly what gearbox does. The main characteristic of any gearbox is ratio.
So you can see here the same variant: engine, electric engine, coupling, and gearbox. Another design, it is a cylindrical, so-called spool transfer, and idea the same: engine, coupling, gearbox, and here driven machine.
Equals the quotient of input speed and output speed. Thus torque is multiplied.
Oops, sorry.
The main characteristic of any gearbox is ratio. It equals the quotient of input speed and output speed. Thus torque is multiplied by the number of times of the ratio. The main part of gearbox is gear. In most cases it is the transmission with involved tooth profile. The gears ratio equals the quotient of the gears teeth number and the pinion's 1. For transmitting motion between parallel shafts, we use a cylindrical gear, which in its turn may have straight teeth. Such gear is called spool gear. We can tilt the axis of the tooth to get cylindrical helical gear. Helical gear works more smoothly than the one which has straight teeth, but there is an axial force which has negative influence on the bearing. To dispose of this disadvantage, we need to make double gear with a mirror angle of teeth inclination. Such gear is called double-crossed helical gear or herringbone gear. Cylindrical gears may be internal and external. So-called planetary gear is based on the transmission with internal gear, and it is characterized by a large gear ratio and high kinematic accuracy. Planetary gears are used in automobile industry and aviation. They are more compact since the torque is split into separate strings. In this case, the torque is split into 3 strings. To transmit rotational movement between the shafts with intersecting axes, we use a bevel gear. Involved tooth profile forms not a cylinder but a cone, so the tooth height is variable. The worm gear is able to transmit motion between skew shafts. Depending on the number and location of gears, we can design different types of gearboxes. The design of any gearbox can be displayed in a kinematic scheme. The simplest type of gearbox is a single-stage gearbox with spool gear. We may put together a gear and a shaft with the help of teeth. Rolling bearings are used to reduce friction during rotation. The bearings are pressed by cups. We also place oil fills into the cups. After this, we need to mount and assemble it to transfer into the gearbox. Closed-type covers, also called blind cups, complete the fixation of shafts. Gearbox is covered with a lid. We need to align it with the help of pin spurs. After this, we just bolt on it. To check the oil level, we use a transparent window. Bleed plug is used for oil draining. Top of the gearbox is equipped with an inspection window and a breather vent. Oil is poured to the set level. The oil level is selected depending on the type of transmission and a linear velocity of the teeth. The bottom of gearbox has a slope to facilitate the draining of oil. Teeth of gear work under great stress. In shafts, bending stress and torsion appear, and in places where there is a sharp change of the form, we have the stress concentrate. Increased stress can lead to the failure of the gearbox and consequently to accidents. That is why all the details of the gearbox have to be calculated for durability. From the calculations we determine all the dimensions of gearbox's parts. After that we proceed to mechanical drawings. The gearbox can consist of several gears or stages. Two-stage gearbox's ratio equals the multiplication of gear ratios of each separate stage. Two-stage gearboxes may have different arrangements. In coaxial gearbox, input and output shafts may have common axes. Here is another variant of the coaxial gearbox. The distinctive feature of this gearbox is that we use attached with bolts covers instead of end plug, and that the expeditious gear is helical. Choice of low-speed stage is wider as it transmits more torque. This is also a two-stage gearbox, but for balancing the load on the shafts, low-speed stage is produced first. We can set gears in the gearbox both horizontally and vertically. We choose vertical arrangement when the motor can't be installed flush with the output shaft. For example, we use vertical arrangement in the bodies of lifting cranes. We use an additional lubricity gear wheel for lubrication gears. This is another variant of arrangement. Here we have one horizontal transmission stage and the other vertical. This is so-called L-shaped outline. In this gearbox, high-speed stage is vertical and low-speed stage is horizontal. Such type of construction can make the gearbox more compact. This is another variant of L-shaped gearbox. In this case, the drive shaft is located overhead rather than below. Here is the opposite. High-speed stage is horizontal and low-speed stage is vertical. In L-shaped gearbox, like in the vertical gearbox, it is necessary to put lubricity gear wheel. High-speed and low-speed stages don't have to be located at a right angle. In this gearbox, we have a longitudinal slot in the body and a hollow output shaft that directly allows putting the gearbox on the shaft of main mechanism. That's why it's called a hinged gearbox. Besides cylindrical gear, we may install into the gearbox other types of gears, for example bevel gear. Here you can see two-stage bevel helical gearbox. Bomb gearboxes become heated due to the considerable friction in the transmission. Therefore, we have to use a cooler. To reduce the friction, one is produced of steel but wheel of bronze. There are not only two-stage, three-stage, but also multi-stage gearboxes. Three-stage gearboxes provide a greater ratio. Most commonly unfurled three-stage cylindrical gearboxes are used. Here you can see an example of five-stage gearbox. The gear ratio of such gearbox can reach 2000. The gearboxes are widely used in different types of industry because of their reliability and simplicity.
So you see that too many variants of gearboxes may be. Of course, you can't make all of them, and that's why we consider the only type, it's a barrel transfer. Barrel transfer means that main element of gearbox is two cone wheels, and another variants, all variants we make will be in different direction of input and output shafts. You see here your variant code, and here HV21 means show you input and output shaft orientation, letters HV, the number of inputs and outputs. 1 means 1, 2, 1, 2, and serial number. For example, this is simplest type HH11 or HV11. It means that input shaft 1, quantity is 1, and it is in horizontal plane. And another variant, input shaft in horizontal, output in vertical, but scheme or diagram is the same. Elements we consider here, engine, barrel transfer, input shaft, coupling, should correct it, clutch, and output shaft. So let's consider these types of gearboxes which we can make in our course project. The simplest one is HH11, or simplest. All of them are not difficult. Simplest in designation. H, it means that input shaft horizontal and 1, and output shaft also 1. See, another side, no. Output shaft. So this is H1, and here also H1. Maybe H H horizontal input and horizontal output, but two outputs. One input, two outputs. And the input and output are in a horizontal plane. Then it's maybe like I shown you. Two inputs, one output. Here, vertical input and one vertical input and two horizontal outputs, one and second. So it is VH 1, 2. VH 1, 2. Like this. In compass drawing 2D it looks like here. Then types with vertical outputs. Input is horizontal H, output is vertical V. H, V. One input, one output. One input, sorry, HV, 1, 1. And H horizontal, H 2, 2 horizontal, and 1 output vertical. So it's HV 2, 1, 2, 1. And finally, I show you, I don't have it in a model, but it looks like this. This path I shown you, it is a H, H, and H, H, and two inputs, two outputs. It is looking like this. Here, second output shaft absent. If you add here output shaft, it will be H, H, 2, 2. So let's consider what we have into these gearboxes. This is HH11 shaft key bearings, input shaft bearing, sleeve second, and ring nut bolts to connect frame and frame cover. Gasket, cover, socket cover, the same spring washer. This is a oil dipstick to measure level of the oil into the gearbox, and hole to see what we have into gearbox and to fill it with gear, and breather vent. These parts, I mean input shaft and output shaft with a gear, are the same for constructively, are the same for all variants, but frames are different. That's why we should pay attention when create frame. You see, it's if we delete this part, we'll have 1 1. So we need to create this part, after that make it symmetrically on another side, and one more. I would like to show you one more.
Для сборки конического редуктора на вал ведомо устанавливается шпонка, колесо зубчатое.
Bearing, frame for bearing, keys, cover, nut and washer, and then all of them are mounted into the frame. Input shaft, bearing, sleeve. Here is a bush, bearing, keys, and the same bolts. Oil dipstick, cover, screws, and plug, oil plug. So we will consider all elements we need to design, and we need to select some standard elements. All elements, there are too many, a lot of elements, we should select screws, bolts, keys, washers, nuts, and so on. So our work will consist of two actions: calculations and designing. Calculating results will be in a workbook. I hope you downloaded it. And the best if you use this workbook in digital form and send me results in a PDF format, and I'll check it and return it, and you'll have file with calculations and corrections. But if you don't have ability to make changes in a PDF file, so it's better, in such case, better you download and print it out and fill it and print it out and send me or show me results in JPEG format. So task. Code we discussed. What does it mean? HV211 and so on. Service life in 1000 hours. Your parameters. I send you link where you can take it, this initial data. Output rotational speed and output torque. These are two parameters we should get from our drive. Our question is to design driving machine. We consider it next class, and we should ensure output torque like here. So these three parameters are fixed. We can't change it. We can change these parameters. And on another side, you should select where is your code and where is your diagram. When you selected this element diagram, you should write here code, service life, output, speed, and torque I shown you. And in task diagram, please diagram like this. But you should show correct diagram according to your task and draw this sketch. If you don't download workbook, you can use this QR code to find it, and COS project and Google Disk. It's place where all elements you can find. Then project of presentation 27 May. What we should prepare, what you should prepare, what should submit. Result of calculation and standard elements should be in explanatory note. I give you the same like it was in a home task. I give you this explanatory note template, and you fill it by hand with your calculations. And graphic part is a gearbox assembly drawing and part list. And as minimum one working drawing, 1, 2, depends on what elements you will draw. What does it mean? Gearbox assembly drawing. It means that you should prepare something like this. So you should draw gearbox, put dimensions, positions, and create the part list. I don't show you the details of these elements, but we will consider it closer to the end. Now I show you that this is original elements, here standard elements. Standard elements should be designated correctly, and sometimes we need to change this table. We'll consider later, closer to the end. Technical characteristic, transfer ratio, torque, and so on. You fill it. And put your dimensions with fits you'll see here. I show you these drawings now, but we will consider each element what we have on this drawing. It's first view and the second view. Maybe different variants of frame. I shown you rounded, but here it is rectangular. Maybe like this, like you saw that too many variants, and you should consider optimal for you. And see here the same input shaft, pinion and gear, output shaft and frame consist of 2 parts. So these are the drawings you should prepare. And explanatory note. Then I show you your percentage. Each your action, each your result will be estimated. Here you see what task stages we consider, and here percentage. It is how many percent for each work, and this it is a increasing order. 1 plus 1, 2 plus 1, 3 plus, and so on. And the week when you should make it. If you don't make it in this week when it is described here, I can put your mark less than it in this table. But control point are bolded 10, 25, 40, 60. You read it what you should do, and I shown you that presentation day is May 27. It means that you should finish your course project 1-2 weeks earlier, and if you make this work according to classes, you'll finish in time. But if you need or if you would like to finish before this presentation day, you can make calculations and design according to this content and at the stages like it's shown. How to calculate, you can see it in course project tutorial. You see here the same stages, kinematic calculation, tooth gearing, shafts, and so on. The same like here, kinematic gearbox, shafts, and so on. So you can make this work faster, that I'll do it if you make work according to these stages. Every stage has examples. For example, here you'll see two examples. Example 1 is a calculation of it's for calculation spur gearbox, spur transfer. We consider bevel transfer. We calculate bevel transfer. That's why for you example 2 is actual. Sometimes you'll see here where you can look at in our YouTube channel. And that's why if you would like to make it faster, you need to make it according to example 2 with your calculations, and you can make it before I tell you in class. So it's very good if you make it faster with the same or with better quality. Quantity. No, quality. Quality and quantity. So like this. So example 2, everywhere you can use like stages descriptions. Then drawings I shown you, and you can find examples all materials are here: course project, English, here tasks, workbook, CPT tutorial, and here will be, now it's absent V21, I'll add it later, will be explanatory note for project V22. And you see here file DME project drawings. What you can find here. Here you see compass drawings. And here you see file libs. Libs means that here you can use standard elements for compass drawing. Engines, formats, bolts, circlips, input shaft. So you can use there instead of find it in compass library. Maybe your compass without library. You can make it. You can take it here. That's all. Then here you see one more software we used there to calculate gear transfer. So you can use new version, gear transfer calculation. It will be after next stage. Next week we make calculation of kinematic of our transfer and select engine, and after that you can calculate gear transfer, and we discuss it later. And finally, here may be useful for you know-how. Know-how, here you see gears, creating of bevel transfer in SolidWorks, step by step. Of bevel gear. If you make gear calculation and I sign your result, and you can make it according to this order. It is in SolidWorks. So you can make it like this. After that we create gear and coordinate one according to another. Creating of bevel transfer in SolidWorks. and you can see it video. Like this. It's not my. It was previous year, but nothing to change. Nothing changing during this year. So, final element description should be today 1% task description. You should fill it in a workbook. I said that you should fill it with your initial data, draw a diagram, put numbers or names here, diagram like this, and description like this. And function of your units. Here you write name, here function. Function shortly may be written like here. Engine converts any type of energy to mechanical one. In our case, we use electric engine, but the same function may be not only in electric engine, it may be internal combustion engine, something else. Potential. Coupling connects engine shaft to the gearbox input shaft. We discussed this question. Input shaft transports energy from a coupling to the pinion and takes loads. Bell transfer transforms speeds, direction, and rotational movement. Output shaft, clutch, frame. I note that coupling and clutch make the same work. Connects this is engine to the gearbox input shaft. This is output to the driven unit. But the difference coupling and clutch is this: that coupling connects constantly. I said it. And clutch can move, and usually it is something like frictional clutch. And in such case, when we have overload power transfer, frictional clutch slips, and we have a relative motion of input output shaft and driven machine, and avoid the overheating the engine overload and overheating engine. This is a difference between clutch and coupling and frame. You'll see. So those who need to make faster can consider and calculate kinematic calculation. And if not, you can do it with me next class. So I think that's all today. Short class, but do you have any questions? Sigun. Anybody listen to me? Sorry. I switched off my sorry. So
Sorry. Sir, I have a question.
yes.
On the code, like I have like three numbers, like VH121. So according to your examples, it was there were two numbers, VH12. But I have three numbers now, like what?
Third digit means number of this task in a group of the task.
Oh, okay, thank you.
Like serial number.
It does not change initial data.
Okay, thank you.
Sigun. He also switched off. Did you listen that I told you? Amani. Gaurav.
Yes, sir.
Operates. I switched off voice, but I hope that you listen that I told you.
Yeah,
Yes.
I did.
Thank you. Where is Sigun? I would like to know when he finished home task. Okay, if you don't have questions, we finish.
So I'm here.
Sigun, what about
Sir.
your home task? Kasim
I have
also.
it with me. I will bring it to school when we resume.
We have quarantine, so that's why you have time after.
Yes. I'm going to. Yeah, I'm going to bring it when we resume back to
Show
school.
me by email.
Okay, no problem, sir. I'm going to send it to you.
Kasim,
Yes, sir.
the same.
Yes, sir. The same thing. I will bring it to you.
Better if we finish home task in online regime, and when we can be in class, you at the same day can.
Okay, sir. No problem. I'll be sending you.
Okay. So, if you don't have questions, we can finish.
Thank you, sir. Goodbye.
By
Okay,
the
sir.
way,
Have a nice day.
just a moment.
Yeah.
Maybe next class I'll cancel. I need to be in business trip, but I don't know. I'm not sure that it will be. That's why, if something changes, I write you message. If you don't get message, it means that we meet at the same time.
Okay.
Okay, sir.
All right, sir.
Okay. So goodbye.
Goodbye. Have a good day.
Have a good day, sir.
Bye.